in this section, we will be looking at this worksheet that I left for you guys, the one that says Solving Systems of Equations by Elimination at the top. So we're going to work several problems from this worksheet together, and then you're going to finish the worksheet on your own. So if we look at an equation like this, it would be really difficult to solve this one with substitution. You've got to solve one of the equations for y. You've got to plug into the other. It's going to be a rather lengthy process. But there is another method that will work really well and can be done very quickly called elimination. So the idea with elimination is what we want to do is we want to line our equations up. And when I say line up, I mean the x's have to be in the same spot, the y's have to be in the same spot, the equal signs have to be in the same spot, and you have to have a number over here. So everything, this is what we call standard form here for these. So everything we've got here is in standard form. And so the idea is that if we add these two equations together, we want something to cancel out. And elimination works particularly well on this particular problem because right now I have a negative 4x and a positive 4x. And if I add those together, I get 0. So these two cancel each other out. Then I could add my negative 2 and my 8, which will give me 6y. And then I could add my negative 12 and my negative 24, which is going to give me negative 36. So now you can see I have a really simple equation where all I have to do is divide by 6 on both sides. And when I do that, y will equal negative 6. So that gives me my y coordinate pretty quickly. Then I'm going to pick one of these two equations to plug back in to find my x. This is going to be a little bit longer than the substitution, but not too bad. I'm going to pick the second equation just because it has fewer negatives, but it really doesn't matter which one you pick. So I would say 4x plus 8, and instead of y, I'm going to put negative 6 equals negative 24. So 4x minus 48 equals negative 24. I'm going to add 48. Whenever I do that, I get 4x equals positive 24. And last, I will divide by 4. So x will equal 6. So my answer to this system of equations is 6, negative 6. Okay. The next one we're going to look at is another pretty simple one because negative 6 and positive 6, if we add these two together, those are going to cancel out. So that would give us 9y equals negative 9. So we're just adding 5y and 4y to get 9y. We add 1 plus negative 10 to get negative 9. We could just divide by 9 really quickly and solve here. So y equals negative 1. And then we're going to do the same thing we did on the last problem so that we can solve. You can pick top or bottom equation. It doesn't matter. I think I'll pick the top one this time. So negative 6x plus 5 times negative 1 equals 1. So negative 6x minus 5 equals 1. So we add 5 to both sides. Negative 6x equals 6. We divide by negative 6, and x equals negative 1. So my answer for this problem is negative 1, negative 1. Okay. Now let's go into a problem that's a little bit more difficult. Still fairly easy, but a little bit more difficult. In this case, if I were to add these together right now, I'd get negative 6x, negative 18y, and negative 48. This does me no good because if I do this, I still haven't, if I do this, I still have, oops, let me do that. If I do this, I still have an x right here and a y, and I can't solve that equation when I have an x and a y. So what we're going to have to do here is we're going to have to do something a little bit different for this problem. Notice that I'm really close to having two things that will cancel out. I've got negative 9y here and another negative 9y here. If just one of those was positive, then the 9y's would cancel out. So what I'm going to do is I'm going to take one of these equations, doesn't matter which one, and I'm going to multiply the whole thing by negative 1. Okay? So top equation, it's going to stay the same. Negative 2x minus 9y equals negative 25. Bottom equation, I'm going to multiply every number by negative 1, which just is going to change the sign. So 4x plus 9y equals positive 23. And we can do that as long as we multiply every number by that negative 1. So if I now add these equations together, here I will get 2x. Here I've got negative 9 and positive 9, which is what I wanted in the first place. Those cancel out. And over here I get negative 2. So I'm just going to have to divide by 2. And x equals negative 1. Now I'm just going to plug back into either one of these original equations. Doesn't matter which one. I think I'll pick the top one. Negative 2 times negative 1 minus 9y equals negative 25. So that's going to be positive 2 minus 9y equals negative 25. I'm going to subtract 2. And so I get negative 9y equals negative 27. I divide by negative 9. And so y equals 3. So my answer for this problem is negative 1, 3. Okay. Let's look at our next problem. We've got another one that's almost going to cancel out. But if I add these together right now, I've got 2 plus 2. That's 4. Does not cancel out. I can fix this by multiplying the whole equation by negative 1 in that bottom equation. I'm just going to change this to a negative, and a negative, and a negative. And so if I do that now, 7x minus 8x is negative 1x. 2y minus 2y, or it's just going to be 0. That'll cancel, which is what I wanted. And then 24 and negative 30 is going to be negative 6. So my last step here is just divide by that negative 1. And so x equals positive 6. I'm going to pick one of these equations. I'm going to go with the bottom one this time. 8 times 6 plus 2y equals 30. So 48 plus 2y equals 30. I'm going to subtract 48. And when I do that, I get 2y equals negative 18. And divide by 2. And y equals negative 9. So my answer for this problem is 6, negative 9. Okay. Here for our next question, we run into a problem here. So I don't have anything that would cancel out right now, even if I change the signs on everything. So in this case, I'm going to have to do a little bit more than I did in the last problem, and I'm going to have to multiply the equation by a number besides negative 1 or positive 1. So first thing I need to do is just pick out which variable I want to get rid of. In this case, I'm actually going to do this problem twice because there's really no difference in which one's easier. So I've got 4x and x, I've got 9y and 3y. So this is a pretty simple problem. I could get rid of the x or the y in this case. Let's try to get rid of the x's in the first way I'm going to do this problem. So what I could do here, I've got a negative 4x. Right now I've just got a 1x in the bottom equation. So if I multiply that bottom equation by 4, and then in the top I'll still have the same equation, negative 4x plus 9y equals 9. But in the bottom now I'm going to have 4x minus 12y equals negative 24. Okay, so I multiplied the 4 to all of the numbers inside of that parentheses there. And so now if I add these together, negative 4x plus 4x is 0. That goes away. So I have negative 3y equals, and then negative 24 plus 9 is going to give me negative 15. I'm going to divide by negative 3. And so y equals positive 5 here. And then I'm going to do like I did on the last problem. I'm going to plug in that 5. I think I'll use the bottom equation this time. X minus 3 times 5 equals negative 6. So x minus 15 equals negative 6. I'm going to add 15 to both sides. So I get x equals 9. So my answer to this problem is 9, 5. Let's see. Actually, I'm going to write this over here so that. Now, this is not the only way you can do the problem. You don't have to do this problem twice, but I'm going to show you another way to do the problem. So I started off with negative 4x plus 9y equals 9, and x minus 3y equals negative 6. So in this case, what I could have done instead is I could have multiplied this bottom equation by 3. Because if I do that and distribute my 3 to everything, look what happens. I would have negative 4x plus 9y equals 9. Top equation stays the same. But in the bottom, I would have 3x minus 9y equals negative 18. And you can see now that my y's would cancel out. So I could cancel those. So I would be left with negative 1x equals negative 9. So if I divide by negative 1, I would get x equals positive 9. Notice that's the answer I got up here. Then I could take that 9 and plug it back into one of the original equations. Doesn't matter which one. Top or bottom will work. Let's use the bottom because it's got a little smaller numbers. So 9 minus 3y equals negative 6. I could subtract 9 from both sides. Negative 3y equals negative 15. Divide by negative 3. And y equals 5. So you can see here, I get the same answer, 9, 5, no matter which one of those variables I get rid of or eliminate the first time. So you just want to pick whichever one looks easiest to you as you're doing the problem. Here's our next problem. Now this problem has one way that's a little bit easier than the other, because if I look at these numbers, I don't have anything that will cancel just as it is. 8 and 6, there's no number I can multiply 8 by to get 6 or 6 by to get 8 unless I use a decimal or fraction. However, 7 times 2 would give me 14. So the quickest way to solve this problem is going to be to multiply that bottom equation by 2. So if I've got 8x plus 14y equals 4, and in the bottom I'm going to have negative 12x minus 14y equals negative 20. So I'm going to cancel those out right there, and that's going to give me negative 4x equals negative 16, and then last step, divide by negative 4 here. So x equals positive 4. So then I'm going to take that 4, I've got to plug it back into one of the original equations. So I would say 8 times 4 plus 14y equals 4, so that's 32 plus 14y equals 4. I'm going to subtract 32. So 14y equals negative 28. I'm going to divide by 14. And so y equals negative 2. And then that means the answer to this problem is 4, negative 2. Okay. 17 gets into the most difficult type of problem that we're going to have, because for 17 there is no number that I can multiply 7 by that will give me 4. There's no number I can multiply 4 by that will give me 7. I cannot multiply 8 by anything that will give me 9, or 9 by anything that will give me 8. So in this case, I'm going to have to multiply both equations. It really does not matter which variable you decide to get rid of in this situation. There's not really one that's easier than the other. I think I will probably start with this one right here, with getting rid of the x's. So in this case, I've got 7 and 4. It will always work if you take the bottom equation, take the number with the x, multiply it by the top equation, take the top equation, the number with the x on top equation, multiply it by the bottom equation. So we're just kind of switching this, except for we do need to pay attention to our signs. So I've got a negative in both of these. One of them needs to be positive. So to make it positive, I'm going to make one of these negative here. I think I'll go with the negative 7 on this side. So I'm multiplying here. I'll have negative 28x minus 4 times 8 is going to give me 32y. And then 9 times 4 is going to give me 36. Okay, so I've multiplied that top equation by 4. Then I'm going to multiply the bottom equation by negative 7. So negative 7 times negative 4 gives me 28. Then I'll have minus negative 7 times positive 9 is going to give me 63y. And that is going to equal, let's see, we've got to do negative 22 times negative 7. Let's grab the calculator for that. Whenever we do that, we're going to get 154. So we get positive 154. So numbers are a lot bigger on these types of problems, but the idea is still the same. We are going to cancel out that 28. Now we're going to get negative 95y equals, let's see, we get a 0 here, 190. And if we divide by 95, or negative 95, I should say, negative 95, we're going to get y equals negative 2. Okay? And you can use your calculator if you need it there. So then, once you've got that, you're just plugging back into one of these equations. Pick whichever one you like. I think I'll go with the top equation here. So negative 7x minus 8 times negative 2 equals 9. So negative 7x plus 16 equals 9. I'm going to subtract 16 from both sides. So negative 7x equals negative 7. Divide by negative 7. And x equals 1. So the answer for this problem is 1, negative 2. Here's another example. We've got a problem where we cannot solve by just getting rid of, we cannot solve by just multiplying by one of these equations. I've got 3 and 5, 2 and 5. Neither one of those are going to work by just multiplying one equation. So I think this time I'll choose to get rid of the y's just to show you that it does not matter. I think, did I do the x's on the last? Yeah, I got rid of the x's on the last problem. So let's get rid of the y's here. So it always works if I take this 5, multiply the top equation by that 5, take the 2, I'm going to multiply the bottom equation by that 2, and then I've got negatives for both of these. One of them needs to be positive, so let's put a negative right here with that 5, just so we can get opposite signs. Now it doesn't matter if I put that with the negative 5 or down here with the 2. Doesn't matter, just don't put it in both places. So if I distribute here, I get negative 15x plus 10y equals negative 10. And then in the bottom, I'm going to have 10x minus 10y equals 20. Okay, so we're just multiplying those equations. Now this works out nicely because my y's will now cancel. So that gives me negative 5x equals 10. And then divide by negative 5. And so x equals negative 2. Alright, once you've got that first answer, you just got to plug it back into one of these equations. I think I'll use the top equation. 3 times negative 2 minus 2y equals 2. And so we get negative 6 minus 2y equals 2. I'm going to add 6, so negative 2y equals 8. I'm going to divide by negative 2. So y equals negative 4. So for our answer, we're going to get negative 2, negative 4. Okay, we're going to do another problem here. Okay, we've got 2x plus 8y equals 6, and we've got negative 5x minus 20y equals negative 15. So this is another example where we're going to have to multiply both equations. Now, in this particular case, I think it's a little easier to get rid of the x's because the numbers are a little smaller here. So I'm going to multiply the top equation by 5 and this bottom equation by 2. And I don't have to change the signs because one's already positive, one's negative. So I'll get 10x plus 8y equals, oh, that's wrong, hold on. Whenever we do this, make sure that you multiply every number by that 5. So you'll have 10x plus 40y equals 30. And then for the bottom of the equation, we'll have negative 10x minus 40y equals negative 30. Now look what happens here. The x's cancel just like I wanted, but the y's also cancel, leaving us with 0 over here. And negative and 30 minus 30 is also 0. Now, when this happens, when both the x's and the y's cancel out, it means you've got one of two situations. You've either got no solution or infinitely many solutions. In this case, it's going to be infinitely many solutions because 0 does equal 0. So we will say infinitely many solutions. If we get something like 2 equals 0 or negative 7 equals 5, something that 0 equals 42, then that is a false statement. So that would be the case where we'd have no solution. Okay, we've got one more that we're going to do together. Let's look at number 23. 23 is kind of a mess because 23 is not in order. And remember I said at the very beginning that our x's have to be lined up, our y's have to be lined up, and our equal signs have to be lined up in order for us to solve these problems. So what we would have to do here, if we're going to use elimination, is we would need to put these in standard form. So for this one on the top, I could just switch the sides of the equal sign. So, and I'm going to put the x first. So I'd have negative 7x minus 20y would equal negative 14. And then for this one, I've got to get this y over here with the x, so I could subtract 10y. And so that gives me 4 equals 2x minus 10y, but it'll be easier if we write 2x minus 10y equals 4. So before you can begin, you have to make sure your x's are lined up, your y's are lined up, your equal signs are lined up, and your numbers are lined up. You cannot solve this problem the way it looks in the beginning here. So once we get that set up, now we're going to look at the problem. Right now, if I add these together, nothing's going to cancel. But this one, there's nothing I can multiply 7 by to get 2 or 2 by to get 7. But right here, if I multiply 10 by 2, I would get 20. And in particular, if I multiply it by negative 2, then I get positive 20, and the y's would cancel. So I'm going to say negative 7x minus 20y equals negative 14. And then right here, I'll get negative 4x plus 20y equals negative 8. And so I've multiplied this bottom equation by negative 2. And whenever I do that, I'm going to add these together. So I'll get negative 11x. My y's will cancel. And it's going to equal negative 22. I will divide by negative 11. and so x equals positive 2. Alright, now you can go back to one of your original equations and plug this in. The bottom one looks a little easier to me, so I'm going to say 10y plus 4 equals 2 times 2. And so that's 10y plus 4 equals 4. I would subtract 4 from both sides. And so I get 10y equals 0. I'm going to divide by 10. And that is going to give me y equals 0. So the answer to this problem is 2, 0. Okay. What I want you to do now is work on the rest of this worksheet. You're going to do as many as you can. In class, you're going to turn it in before you leave.